Okay. Now, so we have learnt into the last turn the singly linked list, and now in this turn we'll try to learn a doubly linked list, right? So as I told to you, what is singly linked list? So singly linked list is a one in which there is only a single pointer. Singly means single pointer, and doubly linked list is a one in which there are two pointers. So that is called as doubly linked list. So in the singly linked list, the node points to only the next node, and in doubly linked list, the node points to its previous node also. That means if we draw it, then we have this node 1, another node. Let's say these are the nodes in the singly linked list, and so if it points, so this points to this one, this points to this points to this, and there is no any node ahead, so this points to null. Okay, so this points to null. And in the doubly linked list, what happens that there is a ahead node, there is a pointer going from the first node to the second node. There is one more pointer going from the second node to first node, its previous node. That means this node will point to something, but there is no any node further, so therefore this will point to null. All right, so this will point to null, so this is a null. And now here they, after this node, in this node there is previous node available. So what will happen that this node will point to this node, this node will point to this node, this node will point to this node. Okay, and so this is the doubly linked list. So in the doubly linked list, the difference is that in singly linked list, number one, there is single pointer that points to next node. So it points to next node. And in doubly linked list, the in doubly linked list there are two pointers. Okay, which are two pointers? The first pointer, or you can call it the next pointer. Next pointer points to the next node, and there is one more pointer called as a previous pointer that points to the previous node. All right, so that's the difference between the two lists, singly linked list and doubly linked list. So what is the advantage of doubly linked list over singly linked list is that you can reverse the list. That is, you can start from the advantage over the singly linked list is that number one, you can traverse in any direction. You can go further, that you can go ahead, or you can come back again. You can come back. That is, both side the traversing is possible. That is, you can go from this node to this node, you can go from this node to this node, and you can even come back from this node to this node. All right, so that is the advantage. Now so now let us see a practical or any assignment based on this doubly linked list. Okay, so the assignment is, let us see. So the next assignment, write C++ program for storing binary number using doubly linked list. Write functions to compute ones and twos complement and add two binary numbers. So now first of all, what we will do? We will try to create the doubly linked list to store the binary numbers. Now we have to create the doubly linked list to store binary numbers. You know that binary number has the value 0 or 1. So we will have now, we will create a data which is in the form of 0 or 1. So now let us see, let us open a C++ compiler and we will work on to that compiler. All right. Is this code visible to all?
Yes. Yes, sir.
Okay, okay. Now, so now let us create a class. So class doubly linked list, DLL. DLL stands for doubly linked list. So what data we need to have? The private data is the Boolean type of data. Boolean means either a value 0 or 1. So let us take a bool. Bool is a Boolean type of data. In C++, the Boolean type of data can be obtained using BOOL, bool. So bool, let us take number. Okay, bool number, that is every node will contain a single number. So our representation will be like this. Our representation of data will be like this. So we'll have a list like this. So this is one node, another node, let's say this doubly linked list, and here it will have a pointer, back pointer, this which is null. This will point to this will point to this will point to this. And let's say now we have to insert a number called as 1 0 0 1 1. Let's say this is a binary number. Okay, this has to be inserted into doubly linked list. So this node will contain value 1, this node will contain value 0, this node 0, then this will point to this will point to this, it will contain value 1, this will point to this, and this will contain 1, and this is pointing to nothing. So it is n. N means null, and here it is also null. There is no any previous node, so it is null. Okay, so we'll create this list. So now let us open the programming environment. So we'll have a pointer, two pointers required, DLL pointer, next, which will point to the next node, DLL pointer, previous, which will point to the previous node. All right. So now let us create a constructor which will construct a node and add the binary value into it. All right. So let us have a public function so that it can be accessed into a main. So functions must be public and data must be private. So in the public we will have now two pointers. This is as we learned that this is a start pointer. So we'll have this as a start, and this is the end pointer. So we'll have this as end. Okay. Initially, if there is no node, then start and end will be equal and it will be null. Okay. So it will be null. All right. So now let us have public static DLL pointer start and pointer end. All right. So two pointers. Now we have a constructor DLL, and now let us write the cout. We will ask to the user enter a binary bit. All right. So bit of the number. So enter the next binary bit. Okay, of the numbers, because we will take it bit by bit. So first user will enter 1, then user will enter 0, then it will enter 0, then 1, then 1. All right. So that way in which it will create the binary number. Okay, so cout enter next binary bit of the number. So we have to accept it. So cin, how to accept it? Cin num. So in that we will enter the binary number. And then the next and the previous initially will be null. Okay, both are pointing to null. And then we'll have a comparison if, because we have to add it into the list. So how do we compare it if it is an empty list? So how to check it whether it is an empty list? So if start equal to null, then it is an empty list. It indicates what? The list is empty. Nothing into the list right now. Okay. So if it is empty, then what we do? We do start is equal to end is equal to this. Okay. This means the current node which has is being called for this constructor, and it is pointed by this. If it is not means that list is not empty. Else, in the else means that list or the number, the DLL doubly linked list is not empty. That is, some node is present into the doubly linked list. Then how to do that? So that means, let's say we have now a new node. Okay, so let us now see how we can create the pointers. So now if it is not empty, that means there is some data available. Let's say it is now the data 1. Assume that we have inserted data 1. So we have this as null, the next is null, and the previous is also null. All right. And this is a start and this is also end. Both are pointing to the same node. Now we have to add one more node with the value, let's say 1. Okay, the next node is 1. So what we have to do? We have to point this to this node. So this we have to do. So how we can do it? So we can do it that start, this start ka next. Next means this pointer. Start ka next, that is next, next is equal to this object, and this object is represented by pointer this. So this is equal to this, and we have to point this, that is the pointer, previous pointer of this, to the start. All right, that means this pointer. So that means this ka previous, this ka previous is equal to start. Is equal to start. Okay, so that's it is. So that's if else start ka next is equal to this pointer, and this ka previous is equal to start.
सर एंड का आएगा ना?
हाँ, एंड भी बोल सकते हैं, एंड भी बोल सकते हैं. Oh sorry, या एंड, sorry, correct. I'm really sorry. एंड का नेक्स्ट, because वो तो पहला है start. What about now we have the next node? Very good. End का next is equal to this का previous is equal to end, is equal to end, and end will change now. End will point to this. Okay, so end now is shifted here. So how to shift it? So end is equal to this. Right. So we now shifted the end. Very good.
हेलो सर.
हाँ, yes.
स्टार्ट का नेक्स्ट लिखा तो भी चलेगा ना? वो
नहीं चलेगा, बट अगर हमारे दो नोड रहेंगे, फॉर एग्जाम्पल इफ दिस इज नॉट द केस, वो दो नोड के लिए ठीक है. मैं अगर ऐसे, मेरी लिस्ट ऐसी है, ये एक है, ये दो है, और थर्ड अभी ऐड किया मैंने. ओके, तो इस केस में क्या होगा? ये इसको पॉइंट कर रहा है, ये इसको पॉइंट कर रहा है. स्टार्ट ये है, ये क्या है? स्टार्ट. ओके, ये इसको पॉइंट कर रहा है, ये इसको पॉइंट कर रहा है. ओके, लेट्स अज्यूम दैट द डेटा 1 is here, 1 is here. ओके, and now and this is 0. Okay, and this is end. Now let's say we have to add one more node with value, let's say 1. So how to add it? Then we have to make it end ka next is equal to this, and this ka previous is equal to end, and end is equal to this, so end will now shift here. All right, so that's how we have to do it. End ka next is equal to this ka previous is equal to end, and end is equal to this. स्टार्ट अगर किया ना तो सेकंड नोड के लिए ही वर्क होगा, अगर थर्ड नोड ऐड किया मैंने तो क्या हो जाएगा, फिर स्टार्ट का नेक्स्ट मतलब ये ऐसे पॉइंट करेगा, ये ऐसे पॉइंट करेगा, तो ये लिस्ट पूरी ये हो जाएगा, ये डैंगल, ये this will now go into dangling. Okay, this will not point to anyone. All right, so this we have to do it. Very good. Who has corrected this? Any the name end का next आना चाहिए, कौन बोला अभी?
सागर
सागर, very good.
सागर
very good. सागर काय नाव? 350. Very good. Now let us see the yes, now this we have created it. Now what we have to we will write the function to display it, so that now at least we are correct or not. So we created it, in this creation is done. Now we'll do a one more function called as display. Okay, so void display, right? So let us so now how to display it? So let's take one pointer DLL, which will traverse DLL pointer PTR is equal to start. Okay, we will start from the start node, and while PTR not equal to null, जब तक वो null नहीं होता है तब तक हम traverse करेंगे, and we will print cout. हमें क्या क्या प्रिंट करना है? नोड प्रिंट करना है, this with the binary bit. Okay, so the binary value, that is how to get it, PTR का num. उसके बाद हमें प्रिंट करना है this end of the box, this. Also we have to print the previous node and the next node. So this is this will point to this. Is there any symbol in which it has the forward pointer also and the backward pointer also? Is there any symbol available that way? We will use this symbol. Okay, this indicates that there is a forward pointer also and the backward pointer also. Okay, we will use this symbol. And this, and here we will have cout. Once it is done, we will print null, that is nothing. Also before this we will print null, cout null, and after that we'll have a and then this points, right? And okay, so now let us see what is our output. Okay, so we'll have a menu driven program. So let us write a menu cout /n menu, and /n on new line, one dot insert insert bit into binary number. Okay, or add, insert, instead of insert let us have add bit into binary number, 2 dot display binary number, display, let's have 3 exit. All right, so now let us take in choice. Before that we will cout enter your choice, whatever is a choice, and we will take that choice, and then we'll have a switch case. switch, choice, and case 1. Case 1 means add the binary number. So we'll have one more, we'll have object, pointer object, DLL pointer obj object, and case 1 will have obj is equal to new DLL. So new node has to be created to add the bit. So the new node is created and we'll break it. Then case 2. Case 2 is that display. So we'll call the display function obj display. Okay, call the function, it will display it and break. And case 3 is exit. Exit 0. All right. So now that's it is. So let us continue while, let us continue it infinitely till the user says I want to exit. Okay. So let's finish the while loop. The while loop is complete and the while loop has started. All right. So this is a menu driven and that will continue for number of times based on if user hits 3, then it will come out of the loop and exit the program. Okay. So we need a choice. So integer choice. Okay. Now let us. We have completed the two functions. The create, that is adding a bit into the doubly linked list, and displaying the doubly linked list. So now let us run it. Okay. Now there is an error in the 29 line. Cout null. 29 line. Here we have not given semicolon. Then while ptr not equal to null. Done. So let us run it. Yes, DLL is not completed. Yes, it is completed. Class DLL boolean num public if else void display. Display is also complete. ptr main is also switch is also complete. While is complete. Main is complete. So what it is giving undefined okay, we have not given reference to the start and the end. Correct. So this reference has to be given. So how to give the reference? So we need to give DLL pointer, DLL start equal to, and DLL pointer, DLL is equal to null. Done. We have given we have initialized the static member. Static members has to be initialized, otherwise that gives the error. So run it. Okay, successfully now compiled. Let us add a bit into the binary number. So enter next bit 1. Add 1. Add 0. Add 0. Let's say now, so 1100 that we have done it. Now let us display it. Oh, it is going infinitely. Why it is going infinitely? Let us see. Display. Oh, sorry, we have not displayed ptr is equal to ptr ka next. We have not went to next node. So we have to go to the next node, isn't it? We have printed the value of the node and then we have to visit the next node. So that is missing. Okay, so that went into infinite loop. Now let us run it again. 1 1 1 1 1 0 1 0. Okay, so our number is 1100. Now let us display it. So it is 1. Previously now it is null. It is pointing to null. Then the first node is 1. It is both way pointing. That is, it is pointing to 1 and 1 is also pointing to 1. Okay. Then 0. So 1 is pointing to 0 and 0 is pointing to 1 and then pointing to 0. All right. Finally, here the null is pointing. Actually, null should not point to anyone. Here end में हमारा जो ये आ रहा है ये अभी सिर्फ सिंगल कैसे ले सकते हैं, ठीक है, doesn't matter, but actually our everything is correct, so this has to be okay. First of all, we'll terminate it using 3. Now this is pointing to the next, doesn't matter. Okay, now what we have to do, we have to do
Just we will shift that in forward.
हाँ ठीक है, doesn't matter. Now we have to do the next part of it, which is 1's complement and 2's complement of the given binary number. Okay, so now let us write a function for 1's complement. All of you know what is 1's complement. That is 1 is converted into 0, 0 is converted into 1. So if we have a number 1 1 0 1 0, then its 1's complement will be 0 0 1 0 1. All right, so that will be the 1's complement. So if it is a 1, write it 0. If it is 1, write 0. And if it is 0, write 1. Okay, so let us write a function for that 1's complement. Okay, so void 1's complement. Right. So how to do now? What is the logic? So the logic is that you visit all the nodes. Okay, so you start from this node, and if it is a 1, print it 0. Then go to the next node. If it is a 1, print it 0. If it is 0, print it 1. And if it is 1, print it 0. So that's 1's complement. So the same thing into the display, what the logic we have used. So DLL pointer PTR, okay, while is equal to start. So we have to start it from the first node. Start, right? While PTR not equal to null, we have to go ahead. And what we have to do? We have to display the value. PTR, the not of it, that is complement of it. So how to display it? So we have to display it cout PTR cout PTR का number, but the not of it. So how to get the not of it into C++? We can get it by the this operator, the not. Okay, so by using this, the 0 is converted into 1 and 1 is converted into 0. This is called as not. This is a logical the operator, not operator. All right, so this we will print it now, and the PTR is equal to PTR का next. Now let us try to see whether we are correct or not. All right, so let us run it. Okay, so choice, let's say 1. Let us insert 1 1 1 1 0 1 0. So our number is 1100. So let us try to print it. Display. So if we display it, the number is 1100. Now let us, oh, I'm sorry, I haven't not given the call the function. So we need to call the function 3 1's complement करने के लिए. So 3 is now 1's complement, and dot is exit. All right, so case 3 is 1's complement. So let us call the function obj 1's complement and break. And case 4, it. All right, so now again run it. So add, I'll just make it short, add bit. Okay, add bit and display ones complement, done, and enter your choice onto the next line. Now, so add a bit 1, add a bit 1, add a bit 0, add a bit 0, right? Now display it first, whether we are correct or not. Yes, 1100 is correct. Now ones complement 3. So ones complement is, answer is 0011. So our output is correct, 0011. Now that means we are correct. Now let us come to a next function, which is 2's complement. Now we have to do 2's complement. Okay, so now what is the logic for doing the 2's complement? 2's complement is done like this. If we have been given a number 1, 1, I'll take the table, will be better. 1, 2, 3. Let us take okay, so this is a, let's take this is a binary number with the value 1, 1, 0, 0, 1, 0, 1. Okay, so this is a given binary number. Then the ones complement will be, its one complement will be 0, 0, 1, 1, 0, 1, 0. That will be its ones complement. And if we, what is a 2's complement? 2's complement is nothing but it's a ones complement and then add 1 to it. So 2's complement, that is first do ones complement, then add 1. So if we add 1 into ones complement, so what will be the value? Answer would be 1 plus 0 is 1, this 1 as it is, this 0 as it is, this 1, this 1, this 0, and this is 0. So that is the 2's complement. Okay, so this is a 1's complement and this is 2's complement. So if we have the number, the next number is like this. Let's assume that number is, this is 0, 0, 0, 1. And so what will be its 2's complement? What will be its 2's complement? First, what we will do? Hello students, is anyone there?
Yes, sir. Yes,
हाँ
sir.
हाँ, तो बोला ना, आता काय करू आपण?
One's complement 001
0,
0
0,
triple one.
1, 0, 111. त्यात 1 ऍड केला, 1 ऍड केला. So what will be the value? 0, then carry 1, 0, carry 1, 0, 1 plus 1 is 0, carry, and here carry, there is no carry here, all right? There is a carry, 1 plus 1 is 0, carry 1, so carry 1 इथे आला. 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, and 0 plus 1 is 1, and then rest as it is 1 0 0. All right. So from this input and the output, can you come out with logic for the 2's complement? So this is the input, this is the input, and this is the output. So can you come out with the logic? So what is the logic for finding 2's complement just by looking at the number? Actual way is that do 1's complement, add 1. That is a forward way of doing it. That's okay. Without doing this, I don't want to do 1's complement, I don't want to add 1. Can you find out any pattern between the input and the output so that you can come to know, or you can find out 2's complement? Can anyone come out with the any logic or pattern?
So from LSB, we will check where is one occurring, and where the first one occur, we will write there one, and then from there forward, we will just complement all the bits.
Okay, very good. LSB means from the last one, na?
Yes, sir.
Okay, from the last we got 0, we'll keep 0 as it is. We got 0, keep 0 as it is. We got 0, keep 0 as it is. We got first one, keep the first one as it is. And then later on, whatever the bits we get it, just complement it. So 0 becomes 1, 1 becomes 0, and this 1 becomes 0. Okay, so now we will apply this logic for this number. Okay, now you tell me what will be the 2's complement of this input. Okay, 1 0 1 1 1 0 1 1 0 0 1 0 0. What will be the 2's complement of this number? Don't do 1's complement and don't add 1. Just by looking at the number, now applying the same logic, just find out 2's complement. As it is told, start from LSB, that is start from here. So we got 0. Okay, so 0 means keep the 0 as it is. Our number is 1011 1011 00 100. Okay, so we will start from LSB. So this is a LSB. So we got a 0, we'll keep 0 as it is. Then we'll go to the previous node. So this 0 will keep it as it is. We got a 0. Now we got first one. So we'll keep that first one as it is. And we got the first one, that's finished. So whatever comes after this, we will just complement it. So 0 becomes 1, this 0 becomes 1, this 1 becomes 0, this 1 becomes 0, this 0 becomes 1, and then this 1 becomes 0. So that is the 2's complement of the given binary number. So this is binary number. What will be the 2's complement of this? 1 0 0 1.
0 1 1.
0 1 1 0.
0
0 triple 1.
triple 1. Okay, very good. Because this is a, we will start from LSB. So this one will keep the 1 as it is. and then whatever comes we will just complement it. So 0 becomes 1, this 0 becomes 1, and then this 1 becomes 0. Done. What will be the 2's complement of this? 1 1 0 1 0. What will be the 2's complement of this? आपने जिन्होंने बोला है अब मत बोलो, वो मत बोलो. जिन्होंने ऑलरेडी आंसर दिया है डोंट स्पीक, जिन्होंने नहीं दिया है दे ट्राई इट. अब क्या आएगा इसका 2's complement? अरे बाकी के कहाँ है, सारे सो गए क्या?
0 0 1 1 0.
0 0 1 1
1 0.
very good, very good. 0 0 1 1 0. Very good. So what logic we will apply? As I told, start from the last node, and if you get the 0, keep it 0 as it is till you get the first one, and once you get the first one, keep that one as it is, and then whatever you get the number in the from back, you just complement it. Okay, so that is the logic that we will apply it. Okay, so let us put that logic in the form of word. So logic for 2's complement. So what is the first step? Start from end node. Okay, start from end node. So continue, that is 0 is kept as 0 till we get first one, and then whatever is there, that is 0, convert it to 1, and 1 convert it to 0 till the null, that is you get the null. Okay, so that we have to do it. So now let us try to implement it. So write a function void 2's complement. Now here we will start from the end. So DLL pointer PTR is equal to end. Okay, we will start from end. And traverse कैसे करना है? We have to come use the previous pointer. Next से हम आगे जाते हैं, previous से हम पीछे आते हैं. Okay, so we'll use a previous pointer. So while PTR का num, while PTR not equal to null, first of all not equal to null, it should not be null, and PTR का num equal to 0. Continue this till it is not null and PTR का num equal to 0. So what we have to print it? Actually we have to print, if we print it then it will give the output like this. As per this logic, it will give the output, this 0 is converted as 0, so it will give the output 0, then 1 is kept as 1, and then complement everything 1 1 0 0 1 0. बट हमें ये रिवर्स में चाहिए. ये कैसे हो रहा है कि ये यहाँ इसका आंसर ये ऐसे आ रहा है अगर हम ऐसे प्रिंट करेंगे तो, क्योंकि लास्ट से प्रिंट हो रहा है. तो हमें कैसे चाहिए? ये हम एक स्ट्रिंग में स्टोर करेंगे. वी विल पुट इट इनटू स्ट्रिंग एनी कैरेक्टर and then we will reverse it. Okay, so we'll have a character any data or character 2's complement, character 2 complement, and let's have some 15 or something like of characters. Oh no, it's not a character, it's a bool data, sorry, bool 2's complement. Okay, and now we'll have one pointer to it also, which will keep track of index integer I equal to 0 initially. Okay, and we'll put it into that. So 2's complement of I is equal to, we have to keep the PTR num or 0. PTR ka num is 0, so we will put it 0. 2's complement of I equal to 0. So we have to go to the PTR is equal to PTR ka previous, right? And initially I is equal to -1, we can keep it, and here we can increment the I plus plus, that is, we'll go to the next location and then put it the value, and PTR is equal to PTR ka previous, that will come to the previous node of it. And now after this, once it becomes 1, it will come out of the loop. It will come out of the loop. What we have to do then, we have to put into the 2's complement. 2's complement of I plus plus I. That is, first we have to increment I, and then so we can combine this I plus plus and this I as plus plus I. So first it will increment the I, and then it will assign the value to that index. So that can be done like this. So 2's complement plus plus I, and first increment I, and then at that location put the 0 value. So same thing can be done here. So 2's complement plus plus I is equal to 1, right? Because it has come out of the loop when it is not 0, all right? So 1, and then we have to continue this while PTR not equal to null. And what we have to do, we have to write down 2's complement plus plus I is equal to PTR ka num. Whatever is a num value, we have to write that. No, sorry, complement of it, not actually. So not of it, not PTR.
Hello sir.
Sir,
while मध्ये PTR of num is not equal to 0 येईल ना?
कुठलं पहिल्या लूप मध्ये का?
हो सर.
नाही, आपण
सर
नाही इक्वल टू 0 असेल तर कंटिन्यू करायचं आहे ना आपला ती ही लूप. हे बघा, परत मी ड्रॉ करतो. बघा परत काय काय होतं. आता लेट्स से आपला हा नंबर आहे 1 1 0 0 1 0 0 0. लेट्स से दिस इज अ नंबर. मग या केस मध्ये काय करतोय आपण, इथून सुरुवात करतोय. हा 0 आपण कसा ठेवणार, हा 0च ठेवणार, नंतर मागे जाणार. ह्या पॉइंटरला आलो, हा 0 मिळाला, हा 0 पण आपण असाच ठेवणार. नंतर मागे आलो, नंतर इथे आलो या पॉइंटरला, नंतर मग हा 0 पण असाच ठेवणार. नंतर मागे आलो, नंतर हा 1 आला, हा 1 आला, हा 1 आपण कसा ठेवणार, हा 1 तसाच्या तसा ठेवणार. पहिल्यांदा पहिला 1 आहे. So same thing here, if while PTR not equal to num and PTR का num equal to 0, हा 0 आहे म्हणजे ह्या लूप ने काय होणार, या लूप ने आपण 0 राईट करत जाणार. 0 राईट करतोय, हे 0 we are writing, and PTR is equal to PTR का previous, we are coming to previous. आता हा इथे लूप कधी स्टॉप होणार, ही लूप कधी स्टॉप होणार, when PTR will now point to 1. म्हणजे ह्या 1 च्या ठिकाणी जेव्हा आला तेव्हा तो स्टॉप होऊन जाणार. तेव्हा मग आपण काय करणार, 1 प्रिंट करणार तिथे. 2's complement plus plus I equal to 1, and then we have to continue this 0 we have to convert it as 1, this 0 convert it to 1, this 1 as 0, this 1 as 0, and then stop. All right, so this is what we are doing. 2's complement plus plus I is equal to not PTR ka num. All right, and now what we have to do, we have to print it the output. So we have to PTR is equal to PTR ka previous. We have to come to the previous node, and then we have to display the output cout -n. 2's complement of the given binary number is, right? So we have to print it. So how to print it, we got that into I. So while I is greater than 0. I contains the
Greater
total
than equal to.
greater than or equal to 0, correct, greater than or equal to 0, and then we have to print its value, that is 2's complement, then I minus minus, we have to decrement the I also, C out 2's complement I minus minus, and then it will decrement the I value and it will print it. All right, so that's it is. Let us now work it out this. Let us,
So
we have
haven't had choice.
yes, we have to add it. We have to add the function 2's complement. So case 4 is now, let's have it as 2's complement, obj 2's complement, we'll call it, and break. And case 5 is exit. So we have to put the into menu /n 5. 4 dot is now 2's complement, and 5 number is exit. All right, so now let us run it. So 1, let us put 1 1 1 1 0 1 0. So we have 1 1 0 0 number. All right, so if we display it, it is 1 1 0 0. Now if we do 1's complement, then it will be 0 0 1 1. 1's complement is 0 0 1 1. Now we have to do 2's complement. So 2's complement will be what? 1 1 0 0 ka it will be 0 1 0 0. Am I right? This will be 0,
Yes,
this
sir.
will be 0, this 1 will be 1 as it is, and this will be complemented. So 0 1 0 0. So let's do a 2's complement. 2's complement of given binary number is 0 0. Why is it giving 5 digit? It is not 5 digit. It has to be, okay, 0. Why it is extra printing 0? 2's complement, we started from I equal to minus 1. Fine. We incremented it, we put it 0. Then we put it plus plus I, we put it. Then while I greater than or equal to 0. So 2's complement I minus minus. So we are printing I initially I is equal to minus 1. Then it has become 0, then incremented, then plus plus I, then plus plus I. Then I is pointing to the last digit. So that is what we are printing. Then I minus minus. Then it is same I. Okay, so let us again display the number. Our number is correct, 1100. Okay, so now five is exit. Now can be done like this also. I is equal to I minus 1. So we go to the previous location. Okay, now let us run it. 1 1 0 1 1 1 0 1 0. So now let us display our binary bits. It is 1 0 1 0 0. Okay, so its one's complement will be 0 1 0 1 1. Correct. 2's complement. What will be the 2's complement of this? It will be 0 0 1 as it is. Then 0 is 1, 1 is 0. So 0 1 1 0 0 has to be 2's complement. So it is 0 1 0. This is correct giving. Why is it giving extra 0? I am not. This one is 0. No, 0. This one is 0. This is 1. Zero zero one. So this is the extra 0 that is there. Why is it giving extra 0? What we have done, while PTR not equal to null and PTR ka num equal to 0. 2's complement plus plus I equal to 0. PTR is equal to PTR ka prev. Oh, we added this 1, but we have not decremented the pointer. We have not go to the previous node, okay, because we are working on to that 1. So PTR, because it is a first node, PTR is equal to PTR ka prev. That we forgot it. We have done, that is what we have done. मैं आपको बताता हूँ कि हमारा क्या गलत हो रहा था. ओके, हमारा ये था मतलब, हाँ मतलब हमारा क्या था, ये इसके लिए 1 0 1 1 0 0 0. तो हम क्या कर रहे थे, 2's कॉम्प्लीमेंट में वो बराबर जा रहा था. मतलब ये 0 का 0 जा रहा था 2's कॉम्प्लीमेंट में, ये 0 का 0 जा रहा था, ये 0 का 0 जा रहा था, और ये 1 का 1 जा रहा था. बट व्हाट अबाउट नाउ दिस 1 ना, वी शुड कम टू दिस पॉइंट ऑब्जेक्ट, बट वी वर एट दिस ऑब्जेक्ट. So we have to come to this, and then this 1 has to be converted into 0. This 0 has to be converted into 1, and then this 1 has to be converted into 0. And then reverse it, and then print it from here till the first one. So now it will give the correct answer, because PTR is equal to PTR ka prev. That was missing this, because we were handling the same object twice. Now let us see. Now 1 1 1 1 1 0 1 1 1 0. Now let us display it. So our number is 1 1 0 1 0. Okay, so its 2's complement will be 0 will be 0, 1 will be 1. So and then rest will be complemented. So it is 0 0 1 1 0. That will be the 2's complement. So let us see 2's complement. Sorry, number is 4. So 2's complement is 0 0 1 1 0. Now it is correct. All right. Everybody got it?
Yes, sir.